Hello friends and my dear students, I welcome you all to my channel. If you are new to my channel or not yet subscribed, then I will highly suggest and request you to please support me by subscribing to my channel and press the bell icon so that you will not miss the notification of my future videos. This video is part of the playlist CBSE Mathematics of class 7 following the textbook of author RS Aggarwal. This video is the first class on the chapter fractions, where I will discuss the types of fractions, comparison of fractions, addition and subtraction of fractions, and solve some selected problems of exercise 2A from the textbook of author RS Aggarwal. So let's get started. Okay, so on the left hand side I have kept my notes on the fractions for class 1 that I will discuss, and on the right hand side I will discuss any concept and will solve the problems. Okay, so let's get started. So what is a fraction? Fraction you have already studied in your previous class, that is class 6, fractions and decimals. So you must be aware of the basic definition of fractions and simple addition and subtraction of fractions. So let's recall what you have studied in class 6. So a fraction is a number of the form p by q, where p and q are natural numbers. Remember that p and q are natural numbers. Natural numbers are the counting numbers, which are 1, 2, 3, 4, 5, 6 and so on. So in the fraction p by q, p is known as the numerator and q is known as the denominator. Now if you find difficulty in remembering which is the numerator and denominator, which I also face this kind of problem quite often. So the way I remember is that the numerator, the first letter is n, which you can remember as north, and denominator, the first letter is d, which is down. So p is in the north and q is in the down. So this way you can remember which is the numerator and which is the denominator. So as an example of fractions, you have the half, 3 by 5, 1 by 1, 2 by 4. 1 by 1 is also a fraction, remember, because any fraction will be of the form p by q, where p and q are natural numbers. So 2 by 4, 9 by 100, etc. Now there are various types of, all the fractions can be categorized into various types. The first one is the decimal fraction. In the decimal fraction, the denominator, that is the q, will be of the form 10 to the power n. That is 10 to the powers of 10, where the power is a natural number. That is 1, 2, 3, 4, 5, 6, like this. So as an example, the decimal fractions are like 2 by 10, 3 by 100, 6 by 1000, let's say 7 by 10,000 and so on. So these are the decimal fraction. Now what are vulgar fraction? Vulgar fraction are those fractions where the denominator is not of the form 10 to the power n. That is, the denominator is not a power of 10, where the power is some natural number. For example, 3 by 5, 21 by 40, 9 by 11, and it could be 7 by 30 and so on. So the denominator is not a power of 10. Now, what are the next is proper fractions. In a proper fraction, the numerator will be less than the denominator. That is, p will be less than q. Example 3 by 5, 21 by 30, 7 by 9, etc. So these are the definitions. I will not do any discussion on the right hand side. I think it will be very, it is straightforward to understand. So proper fraction, the numerator will be less than the denominator, that is, the p will be less than q. Now what is improper fraction? It is the opposite of proper fraction, that is, the numerator will be greater than the denominator, greater than or equal to denominator, that is, p will be greater than or equals to q. Example fractions, example of improper fractions are 5 by 3, you see the 5 is greater than 3, 2 by 1, 2 is greater than 1, 4 by 4, 4 is equal to 4. So the numerator is greater than equal to the denominator. Okay, mixed fraction. Now, mixed fraction is of the form n p by q, where n is a natural number. Natural number means starting from the counting numbers 1, 2, 3, 4, 5, 6, and p by q will be a proper fraction. So, for example, you can see now in your previous classes, I guess you have already studied that a mixed fraction of the like let's say 2 upon it is read as 2 upon, let's say, 1 by 4. This is basically 2 plus 1 by 4. So 2 is the natural number and 1 by 4 is the proper fraction. So this is the natural number and this one is the proper fraction. Okay, so likewise you can have one, let's say 2 by 5. This is 1 plus 2 by, remember that p in the mixed fraction p by q on the left hand side, please see the notes, follow the notes. P by q should be a proper fraction. So for example 2 6 by 5, this is not a proper fraction. This is not a mixed fraction because 6 by 5 is not a proper fraction. 6 by 5 is an improper fraction. This is not a mixed fraction. So 2 upon 6 by 5 is not a mixed fraction. But these are all mixed fraction. So in the mixed fraction you have two parts. First part is the whole, that is a natural number, and the other part is a proper fraction, that is p by q, and you can write. So basically n upon p by q is equals to n plus p by q. Now you can always convert a mixed fraction into an improper fraction and an improper fraction into a mixed fraction. So on the example you can see the mixed fraction 1 upon half is basically equals to 1 plus half, and if you do the math of 1 plus half, it is basically 3 by 2. So now 3 by 2 is a improper fraction because 3 is greater than numerator, 3 is greater than 2, the denominator. Likewise, you can convert the mixed fraction 9 by 7, the improper fraction 9 by 7, because numerator 9 is greater than 7, into a mixed fraction, as you can write 9 by 7 as 7 plus 2 by 7, and then if you split into two parts, you will get 7 by 7 plus 2 by 7, which is 1 plus 2 by 7, and 1 is a natural number and 2 by 7 is a proper fraction. So you can always convert a mixed fraction into improper fraction and improper fraction into a mixed fraction. Okay. Now one property of a fraction is very important. You must remember that when you multiply or divide both the numerator and the denominator of a fraction by a non-zero number, then the fraction remains the same. Meaning, so on the left hand side you can see if p by q is a fraction, if you multiply both the p and q with a non-zero number which is a in the on the notes, so p by q will be equals to p into a multiplied by a divided by q multiplied by a. Also you can divide both the numerator and the denominator with the same non-zero number. So for example I can say 4 by 7 is equals to, I can multiply both 4 and 7 by the same non-zero number, let's say 5. I can do this and they will be the same fraction, and this becomes 20 by 35. So the fractions 4 by 7 and 20 by 35 are basically same. They are same. They have same value. Also, let's say I have 10 by 16. I can divide both the numerator and the denominator by 2, and I can have like this. By doing this, both the fraction will be same, and this becomes 5 by 8. So this property you must know that when you in a fraction, when you multiply both the numerator and the denominator, multiply or divide with the same non-zero number, the fraction remains the same, the value remains the same. Now the next type of fraction, the equivalent fractions, is basically based on what we just discussed. So what are equivalent fractions? When you we have a given fraction p by q, and when you multiply this given fraction p by q, when you multiply or divide both the numerator and the denominator of this given fraction p by q, you get an equivalent fraction. So basically you have a fraction p by a given fraction p by q. Now when you multiply, or let's say when you multiply both the numerator and the denominator by a non-zero number a, let's say, then these two fractions are equivalent, are known as equivalent fractions. Or else this was by multiplying both the numerator and the denominator with the same non-zero number a. You could have also divide both the numerator and the both the denominator and the numerator by the same non-zero number a. So these two will also be equivalent fractions. Remember that the number a must be non-zero. You cannot multiply or divide by 0. So division by 0 is anyway not possible, is not allowed in mathematics. But you can you should not over here a must be a non-zero number. This you must remember. So what is equivalent fraction? When you have a given fraction p by q, and when you multiply both the numerator and the denominator with the same multiply or divide with the same non-zero number, then you get a different fraction, and these two fractions are called equivalent fractions. On the left hand side, you can see as an example, so 5 by 4, the fraction 5 by 4 is equivalent to the fraction 5 into 2 divided by 4 into 2, which is 10 by 8, and also it is equivalent to 15 by over here the third one is a mistake, 5 by 3, 5 multiplied by 3 divided by, it should be 4 multiplied by 3, so 15 by 12. Also the second example, you can see 9 by 3 is equivalent to 36 by 12, which is 9 by 3 is also equivalent to 45 by 15. So we are in the first case we are multiplying the numerator and the denominator with the number non-zero number 4, and in the second case we are multiplying both the numerator and the denominator with the non-zero number 5. So this is equivalent fractions. Okay. Now like fractions. A given so what are like fractions? If when you are given a few fractions, fractions having the same denominator and different numerators are called like fractions. So when you are given a collection of fractions, if they have the same denominator but the numerators are different, then they are called like fractions. For example, 2 by 5, 3 by 5, 11 by 5 are like fractions because all have the denominator 5, but the numerators are different. So the numerators are 2, 3 and 11, they are different. Another example is 12 by 7, 11 by 7 and 2 by 7. Over here the denominators are same 7, and the numerators are different, like 12, 11 and 2. Now, what is unlike fractions? Fractions having different denominators are called unlike fractions. If two fractions have a different denominator, then they are unlike fractions. For example, 2 by 5 and 7 by 9 are unlike fractions because the denominators 5 and 9 are different. Similarly, 7 by 9 and 4 by 11 are unlike fractions because the denominator 9 and 11 are different. Irreducible fractions. What are irreducible fractions? Also, this is known as a fraction in simplest form. So, a fraction p by q is said to be irreducible if the highest common factor, that is the HCF of the numerator and the denominator, is 1. This means that the numerator and the denominator have no common factor other than 1. So, for example, 2 by 3, this is a fraction, this is a irreducible fraction because the denominator, because 2 and 3, the HCF of 2 and 3 is 1, they have no common factor. Another one is 4 by 5, another one is 7 by 9. But let's say 2 by 4 is not irreducible, is not irreducible because the denominator and the numerator 2 and 4 have a common factor of 2, and so the HCF of 2 and 4 is not 1. So this is not a irreducible fraction, meaning it can be further reduced to some to a different fraction, basically to another equivalent fraction. So if you divide 2 by 4, the fraction 2 by, if you divide both the numerator and the denominator by 2, we get if you do this, we can do this always. So this becomes 1 by 2. Now half is irreducible. So this is irreducible fraction. But 2 by 4 is not a irreducible fraction because it can be further reduced to half. Okay. Now, how do we convert unlike fractions to like fractions? So this is an important concept which will be used in addition and subtraction of fractions. So the step 1 is, so you are given 2 or more unlike fractions, and the task is to convert all the unlike fractions to like fractions, meaning to convert all the fractions to equivalent fractions where all of the fractions will have same denominator but different numerators. So what are the steps? You first find the LCM of the denominators of the two unlike fractions. So of the two unlike fractions, okay. Now you change the two given fractions to their equivalent fractions, where the equivalent fractions will have the denominators equal to the LCM computed in step 1. Let's see an example. Try to understand this with an example. So as an example, we are trying to convert the fractions 2 by 7, 5 by 14 and 9 by 5 into like fractions. As you can see, these three fractions are unlike because the denominators are different. 7, 14, 5 are different. They are unlike fractions. So what do we do? As a step 1, we find the LCM of 7, 14, LCM of the denominators of the given fractions, which are 7, 14 and 5. So the LCM of 7, 14 and 5 is 70. Now I hope you know how to find the LCM of given numbers. So how do we do? So we have, let's say over here we are trying to find the LCM of 7, 14 and 5. We write it as 7 dash 14 dash 5, and then we try to divide these numbers, three numbers, with the prime number, with a prime divisor. So we can see that 7 will divide 7 and 14. So we first have 7, and 7 is a prime number, and we have when we divide all the three numbers by 7, we get 1, 2, and this is remains as 5. Now we divide the given numbers with a prime divisor, which we can use 2. So this becomes 1 minus 5, and the 5 remains this. So on the left hand side, so the LCM of 7, 14, 5 becomes 7 into 2 into 5, which is basically 70. So okay, so you first find the LCM of the denominators. In this example, it becomes 70. Now you convert the given fractions into equivalent fractions where the denominator will be 70. So 2 by 7, when you convert 2 by 7, what you just do is you multiply both the denominator and the numerator of the fraction 2 by 7, so that the denominator becomes 70. Now what was 70? 70 was the LCM of all the denominators of the given fractions. Now to make denominator 70, we have to multiply by 10. So we multiply both numerator and denominator by 10, which becomes 20 by 70. So 2 by 7, its equivalent fraction becomes 20 by 70. Similarly, 5 by 14, to convert 5 by 14 to its equivalent fractions, so that the denominator is 70, we have to multiply both the numerator and the denominator by 5, and it becomes 25 by 70. Similarly, 9 by 5 becomes 126 by 70. So now we see we got three equivalent fractions where all the denominators are same, which is 70. So the like fractions are 20 by 70, 25 by 70, and 126 by 70. So this is how you convert a given unlike fractions, collection of given unlike fractions into like fractions. Okay. Now how do we compare fractions, like which fraction is greater or which fraction is lesser, or whether two fractions are equal or not? So when you compare two fractions, let's say we have two fractions a by b and c by d. So we are comparing two fractions. Let's say the first fraction is a by b and the second fraction is c by d. Now a by b will be greater than c by d only when AD will be greater than BC. So what you do is, so let's say we have given two fractions 2 by 3 and 4 by 9, let's say. Now you want to determine whether the fraction 2 by 3 is greater than 4 by 3 or less than 4 by 3 or equal to 4 by 3. What you do is you cross multiply like this the numbers. So 2 into 9, 18, and 4 into 3 is 12. Definitely 18 is greater than 12. Since 18 is greater than 12, this implies 2 by 3 is greater than 4 by 9. Is greater than 4 by 9. Let's take another example. And again, and if on the left hand side on the note, you see if the fraction a by b will be less than c by d if AD is less than BC, and in the third case the fraction a by b will be equals to c by d if AD equals to BC. So basically you cross multiply the numbers and you compare those numbers. Let's say we have let's say we have a fraction 5 by 6 and 10 by 12. So basically these are two equivalent fractions and they must be equal. So now how do we compare these two fractions 5 by 6 and 10 by 12? We cross multiply and see by cross multiplication we get 60 and 60. So 5 into 12 is 60 and 6 into 10 is 60. So this is equal. This implies 5 by 60 equals 10 by 12. So this is the basic concept. So if you have say if you have two fractions p by q and r by s, what you do is you cross multiply like this the numbers, and you get p into s, q into r, and then you compare these two numbers ps into qr. If if ps is less than qr, this implies p by q will be less than s by r by s. If ps is greater than qr, this implies, the implication is on both sides, because if if ps is less than qr, then this means that p by the fraction p by q is less than r by s. Also, if the fraction r p by q is less than r by s, then it will also imply that ps is less than qr. So the implication is on both sides. So if ps is greater than qr, this will imply the fraction p by q is greater than the fraction r by s. And lastly, if ps equals to qr, this will imply the fractions are equal. So this is the way we compare two fractions. Now how do we compare more than two fractions? So first we for comparing three or more fractions, we have three steps involved. In the step 1, we find the LCM of the denominators of all the fractions, given fractions, and let's say the denominator is m. The LCM of the denominators of all the fractions is m. Now now in the step 2, we change all the given fractions into like fractions having m as the denominator. So we convert all the given fractions into the equivalent fractions, and all the equivalent fractions will have the same denominator, which is m. And what is m? M is the LCM of the denominators of the given fractions. Now in step 3, we just compare now the numerators of the equivalent fractions, and based on the comparison of the numerator of the equivalent fractions, we can we can compare the original given fractions. As an example, see, it asks to arrange the following fractions in ascending order. So as step 1, what we do is we first find the LCM of all the denominators of the given fractions. So we find the LCM of 4, 6, 9 and 12, which comes out to be 36. Now we convert all the given fractions into like fractions, where the like fractions will have the same denominator, which is 36. So in doing that, we get the like fractions are from 3 by 4 we get 27 by 36, from 5 by 6 we get the like fractions as 30 by 36, 7 by 9 becomes 28 by 36, and 11 by 12 becomes 33 by 36. So the like fractions we got are 27 by 36, 30 by 36, 28 by 36 and 33 by 36, and clearly we can see that if we try to arrange these like fractions in ascending order, we will have 27 by 36 is less than 28 by 36, is less than 30 by 36, is less than 33 by 36. So as a result, as a conclusion, we can say that the fractions, the ascending order of the given fractions, original fractions, will be 3 by 4 is less than 7 by 9 is less than 5 by 6 is less than 11 by 12. Okay, so now we need to understand how do we do addition and subtraction of fractions. So addition and subtraction of like fractions is very easy. So if you have two fractions, two like fractions, let's say a by b plus d by, if we are asked to add two like fractions a by b and d by b, what we do is we simply add the numerator, and the denominator remains the same, because the like fractions have the same denominator. In this case it is b, so the result becomes a plus d by b. Similarly, when we subtract the like fractions a by b or d by b from a by b, we get a by b minus d by b equals to, we subtract the numerators and the denominators remains the same, which becomes a minus d by b. Now, how do we add subtract unlike fractions? In the first case, we discussed how to add subtract like fractions. Now, how do we add subtract unlike fractions? We have two steps. In the first step, we change all fractions into like fractions. As we have discussed earlier before, we change all the given unlike fractions into like fractions, and then we perform the addition and subtraction of the like fractions using the rule 1. So, two steps are involved for addition and subtraction of unlike fractions. Now, addition of fractions follows two properties. So, addition of fractions is commutative. That is, if you add two fractions a by b and c by d, we will have a by b plus c by d equals to c by d plus a by b. Just like addition of integers or whole numbers, the natural numbers are commutative. Similarly, the addition of fractions is also commutative. Also, the addition of fractions is associative, meaning if you have three fractions a by b, c by d and e by f, we can do their addition first by adding a by b with c by d and adding the result with e by f, or we can do the addition by first adding c by d with e by f and then adding the result with a by b. Okay, that was a discussion on the theoretical part of the topics that we will cover in this class number 1. Let's try to apply these concepts in solving some selected problems from the textbook of RS Aggarwal. So, this is exercise 2A. I have also mentioned the question numbers. So, let's solve the problems of exercise 2A. So, the first problem is third part of question number 1. It says compare the fractions 11 by 12 and 15 by 16. So, we need to compare two fractions, and we know that for comparing two fractions, we can use the cross multiplication method. So, what we do is we cross multiply the numbers like this and see that we find the numbers are 11 into 16 and 12 into 15. This is 11 into 16 is 176 and 12 into 5 is how much is 192? No, this is 180. I hope I am right. If I am wrong, please do let me know in the comment section, because I am prone to make mistakes. So 11 into 16 is 66 and 11, 176 and 180. So clearly we can see that 176 is less than 180. So this implies 11 by 12 is less than 15 by 16. Okay. The next question is part 2 of question number 2. Arrange the following fractions in ascending order. Okay. So we see we are given some fractions which are obviously unlike fractions, and we have to arrange them in ascending order. So the given fractions are 4 by 7, 7 by 10, 11 by 15 and 17 by 20. So if you recall, the first step will be to find the LCM of the denominators of the given fractions, which is the LCM of 5, 10, 15 and 20. So if we quickly find the LCM, let's see what it comes out. We have 5, 10, we have 15, we have 20. So clearly we can divide by 5, which is the prime number 5, and we get 1, 2, 3 and 4. Next we can divide by 2, which is also a prime number. So we have 1, 1, 3 and 2. We can again divide by 2 and we get 1, 1, 3, 1, and finally we divide by 3, we get 1, 1, 1, 1. So the LCM will become LCM will become 5 into 2 into 2 into 3. This is 10 into, this is 60. Okay, so LCM is 60. Step 1, we found the LCM of the denominators of the given fraction. Now, in step 2, we have to convert all the given fractions into the equivalent fractions so that the denominator is 60. So 4 by 5 can be converted to equivalent fractions with 60 as denominator by multiplying with 12, because 5 into 12 is 60. So this becomes 48 by 60. Okay. 7 by 10 can be converted to its equivalent fraction where the denominator will be 60 is by multiplying the denominator by 6 as well as the numerator with 6. So we have 42 by 60. Okay. 11 by 5 can be converted similarly as 5 into 12. Now this becomes 12 into 132 by 60. I hope I am right. No, 22 and 11, 22 and 11, yeah, 132. And finally we have the fraction 17 by 20. 70 by 20 becomes 70 into 3, 20 into 3, this becomes 51 by 60. So we have converted all the given fractions into equivalent fractions, and these are the equivalent fractions we have got where all the denominators are same, that is 60, and 60 is basically the LCM of the denominators of the original given fractions. So clearly we can see, if we arrange the equivalent fractions in the ascending order, we get 132 by 60 is in ascending order, sorry. So first will be the lowest one, the least one. 42 by 60 is less than 48 by 60 is less than 51 by 60 is less than 132 by 60. So this implies the ascending order of the original given fractions becomes 42 by 60 was 7 by 10 is less than 48 by 60 was 4 by 5 less than 51 by 60 was 70 by 20 and less than 11 by 5. So this is the ascending order of the given fractions. Okay. Now 5 1, find the sum of 5 by 9 plus 3 by 9. So in adding two fractions of like fractions, because in this case the fractions are like fractions having the same denominator 9, what we do is we simply add the numerator and keep the denominator same. So this becomes 8 by 9. Okay. 6 part of 5 is find the sum 8 upon 3 by 4 plus 10 upon 2 by 5. So we are given two mixed fractions. So how do we add two mixed fractions. First, we convert the mixed fractions into improper fractions. One way is you convert both the mixed fractions to their equivalent improper fractions, which will be uh, uh, 32 plus 3 by 4 plus 50 plus 2 by 5. This is 35 by 4 plus 52 by 5. Now we have to add these two fractions. These are unlike fractions, and we have to convert these first to like fractions by making the denominator same. I will LCM of, so first we have to find the LCM of the two denominators. So over here, LCM of 4 by 5 is 20. So we have to convert the fraction 35 by 4 into its equivalent fraction, where the denominator will be 20. So which will be 35 into 5 by 20, plus also we have to convert the fraction 52 by 5 to its equivalent fraction, where the denominator will be 20. So which becomes 52 into 4 by 20. So now we have two like fractions, and we can just add the numerator and keep the denominator same. This is this. Now if we do simplify, we will have 25 175 plus 208 by 20. This becomes 13 8 380 by 20. You can leave it like this, or you can also convert this to a mixed fraction. Now this was one way of adding two mixed fractions by converting the two individual mixed fractions to their improper fractions. Now we could have also done in a different way, like we have 8 3 by 4 plus 10 2 by 5. We know that the mixed fractions 8 upon 3 by 5 is basically 8 plus 3 by 4. We know this. Also, the 10 upon 2 by 5 is 10 plus 2 by 5. Now we can individually add the two natural numbers. So we have 10 plus 8, and we add the two fractions 3 by 4 plus 2 by 5. So this is 18, and 3 by 4 plus, if I add 3 by 4 plus 2 by 5, I am skipping the steps. We need to convert them to equivalent fractions with the same denominator, which will be the LCM of 4 and 5. So this will become 15 by 20 plus 8 by 20. So I have converted 3 by 4, the fractions 3 by 4 and 2 by 5 to equivalent fractions, so that they have the same denominator 20. 20 is the LCM of 4 and 5. So this is 18 plus this will be 15 plus 8 by 20. This is 18 plus 23 by 20. This is 18 plus 20 plus 3 by 20. This is 18 plus, this will be 20 by 20 plus 3 by 20. This will be 18 plus 1 plus 3 by 20. This is 19 plus 3 by 20. So now this is basically the mixed fraction 19 upon 3 by 20. Okay, so this should be equal to what we got earlier, 383 by 20. Should be. If it is not, then I might have done some mistakes. But I hope you have got the idea of how to add two mixed fractions. Okay. Now let's do 7. It asks to simplify 8 upon 5 by 6 minus 3 upon 3 by 8 plus 1 upon 7 by 12. Now it's better to split the mixed fractions into the natural number plus the proper fraction, like this is equals 8 plus 5 by 6 minus this is 3 plus 3 by 8 plus 1 plus 7 by 12. Now you bring together all the natural numbers, you group all the natural numbers with the operations, we get 8 minus 3 plus 1, and we have keep all the fractions together, we have 5 minus 6 minus 3 by 8 plus 7 by 12. So this is 9, this is 6 plus 5 by 6 minus 3 by 8 plus 7 by 12. Now we have to do compute the addition and subtraction of the fractions. How do we do that? We see that the fractions are unlike fractions. We have to first convert. So now we are doing 5 by 6 minus 3 by 8 plus 7 by 12. So we have unlike fractions. We will first convert them to equivalent fractions having the same denominator. The same denominator will be the LCM of 6, 8 and 12. So LCM of 6, 8 and 12 I guess is 24. So this becomes, if we convert the fraction 5 by 6 to its equivalent fraction with denominator as 24, it will become 20. We have to multiply with 4 both numerator and denominator, so it becomes 20 by 24 minus this will become 9 by 24, and this will become 14 by 24. Now we have the same denominator. What we do is we just add and subtract the numerators and keep the denominator same. So this becomes 34 minus 24, this is, how much is this, 25 by 24. Okay, so this is 25 by 24. So the final answer is 6 plus 25 by 24. Now 25 by 24 can be, this is a 25 by 24 is a improper fraction which can be converted to which is basically 1 plus 1 by 24. So this becomes 7 plus 1 by 24. So this is, if you, so in the mixed form this becomes 7 upon 1 by 24. Okay. The last problem, 12, it says what should be added to 7 of 4 by 15, what should be added to get 8 of 2 by 5? Okay, fine. So this question mark, let's say this, instead of this question mark, let's say we have, if we say that the number that should be added to 7 of 4 by 15 is x, we can clearly say that x will be 8 of 2 by 4 minus 7 of 4 by 15. Now we have to do this subtraction. Let's write it, split the split the whole part and the proper fractions. We get 2 by 5 minus 7 plus 4 by 15. Now 8 minus 7, if we group the natural numbers and the fractions, we have this becomes 1 plus 2 by 5 minus 4 by 5. Now I am directly computing the value of 2 by 5 minus 4 by 15. We have these are unlike fractions, but the denominators are different, 5 by 15. So we have to convert them to like fractions. The denominator as 15, and we get 6 by 15 minus 4 by 15. This is 6 minus 4 upon 15. This is 1 plus 2 by 15. This equals basically the mixed fraction 1 of 2 by 15. So this must be 1 of 2 by 15 must be added to 7 of 4 by 15 to get 8 of 2 by 15. So that is all for this today's video on of class 1 on the chapter fractions of class 7 CBSE board, following the textbook of author RS Aggarwal. If you found this video beneficial, then I will highly appreciate. Please support me by subscribing to my channel and share this video with your friends and colleagues, and so that it will help me grow my channel, and will also motivate me to come up with more of this kind of videos on regular basis. So yeah, that's it. Thanks for watching, and until the next video, take care and bye.